Determinants by expansion of minors. The minor of an element of a determinant order n is the determinant of order n-1 obtained by deleting the row and the column in which element appears. For example, a is equals to -1, 4, -7, 2, -5, 8, -3, 6, -9. So, we're asked to find the determinants by expansion of minors of each number. So, to get the determinants by expansion of minors of each number, simply delete the row and the column in which the element appears. So, for -1, -5, 8, 6, -9. Cross-multiply it to get the determinants. -5 times -9 minus 8 times 6. 45 minus 48 equals to -3. For 4, -2, 8, -3, -9. Cross multiply 2 times -9 minus 8 times -3. -18 minus -24 equals +6. For -7, 2, -5, -3, 6. Cross multiply 2 times 6 minus -5 times -3. 12 minus +15 equals -3. For 2, 4, -7, 6, -9. Cross multiply 4 times -9 minus -7 times 6. -36 minus -42 equals +6. For -5, -1, -7, -3, -9. Cross multiply -1 times -9 minus -7 times -3. +9 minus +21 equals -12. For 8, -1, 4, -3, 6. Cross multiply -1 times 6 minus 4 times -3. -6 minus -12 is equals to +6. For -3, 4, -7, -5, 8. Cross multiply 4 times 8 minus negative 7 times negative 5. 32 minus positive 35 equals to negative 3. For 6, negative 1, negative 7, 2, 8. Cross multiply negative 1 times 8 minus negative 7 times 2. Negative 8 minus negative 14 equals to positive 6. For negative 9, negative 1, 4, 2, negative 5. Cross multiply negative 1 times negative 5 minus 4 times 2. Positive 5 minus 8 equals to negative 3. Determinants using expansion of minors. To get the determinants using expansion of minors, simply delete the column and row in which the element appears. For example, negative 5, 3, 1, 0, 1, 0, 2, 8, negative 6. So, I will use row 2 because it has a 0, but it depends upon you what you want to use, but I will use row 2. So, for 0, three, 1, 8, 6. Cross multiply 3 times 6 minus 1 times 8 equals to 18 minus 8 equals to 10. For minor of 1, 5, 1, 2, negative 6. Cross multiply 5 times negative 6 minus 1 times 2. Negative 30 minus 2 is equals to negative 32. For minor of 0 again, negative 5, 3, 2, 8. Cross multiply negative 5 times 8 minus 3 times 2. Negative 40 minus 6 is equals to negative 46. So, after getting the minor, next is getting the cofactor. Cofactor of 0 is equals to negative 1, 2 plus 1. 2 is for the row and 1 is for the column. Multiply by 3, 1, 8, 6. So, negative 1 raised to 3 times 10 equals to negative 1 times 10 equals to negative 10. So, the cofactor of 0 is negative 10. For the cofactor of 1, negative 1 times 2 for the row and 2 for the column, multiply by 5, 1, 2, negative 6. So, negative 1 raised to the 4th power times negative 32 for the result of the minor is equals to positive 1 times negative 32 is equals to negative 32. So the cofactor of 1 is negative 32. So for the cofactor of 0, negative 1 times 2 for the row and 3 for the column, multiply by negative 5, 3, 2, 8. So, negative 1 raised to the 5th power times negative 46 for the result of minor is equals to negative 1 times negative 46 is equals to positive 46. So the result of the cofactor of 0 is 46. So after getting the minor and the cofactor, next is getting the determinant. To get the determinant, simply multiply the element to the result of its cofactor. So, 0 times negative 10 plus 1 times negative 32 plus 0 times 46. So, 0 plus negative 32 plus 0. The determinant is negative 32.
Cofactor. The cofactor of an element of a determinant in the ith row and the jth column is the product of the minor of the element and negative 1 to the power of I plus j. For example, a is equal to negative 1, 4, negative 7, 2, negative 5, 8, negative 3, 6, and negative 9. To get the cofactor of negative 1, simply delete the row and the column for which the element appears. Negative 1 times negative 1 to the power of 1 plus 1, negative 5, 8, 6, negative 9 is equal to 1 times cross multiply 5 and negative 9, negative 5 times negative 9 minus 8 times 6, 1 times 45 minus 48 is equal to 1 times negative 3 1 times negative 3 is equal to negative 3. So, the cofactor of negative 1 is negative 3.
Determinants by expansion of minors. The minor of an element of a determinant order n is the determinant of order n minus 1 obtained by deleting the row and the column in which element appears. For example, a is equals to negative 1, 4, negative 7, 2, negative 5, 8, negative 3, 6, negative 9. So, we're asked to find the determinants by expansion of minors of each number.
Next is the cofactor of negative 7. So, the cofactor of negative 7 times negative 1 to the power of 1 plus 3, 2, negative 5, negative 3, and 6 is equal to 1 times 2 times 6 minus negative 3 times negative 5 is equal to 1 times 12 minus 15 equal to 1 times negative 3 is equal to negative 3. So, the cofactor of negative 7 is equal to negative 3.
Okay, so this is the transpose matrix. I have two examples here. One is letter A and letter B. In our letter A, the size of our matrix is 2 by 2. So all we have to do is change the row and the columns. So our row 1 is 2 and 6, so we'll just put it in the first column, just like that. 2, 6, and the second row 4, 8. Just put it in the second column 4 and 8, just like that. So in letter B, we'll just do the same. We'll put the first row and also in the first column. So 1, 4, 7 is here, 2, 3, 9 is in the second column, then 5, 6, and 8 is in the third column. So that's the answer.
Inverse matrix. Inverse matrix is equal to adjoint matrix over determinant of matrix. Adjoint matrix is also equals to transpose of cofactor matrix. And determinant A is equal to determinant of matrix. After we get the cofactor of each elements of matrix A, we need to find the adjoint matrix of A. To find the adjoint matrix of A, we need to transpose all the rows to columns and all columns to rows. 3, negative 2, negative 4, and positive 1. And now, that's our adjoint matrix of A. Next, find the determinant of A. Before we get the determinant of A, we need to choose if it's the first row, second row, or the first column, or the second column. And we choose the first row. 1 times the cofactor of its 1, 3, plus 4, and its cofactor, negative 2. Next, simplify. 3, 4 times negative 2 is negative 8. And simplify. 3 plus negative 8 is equals to negative 5. Negative 5 is our determinant of A. And now, we will find the cofactor of 1, where is equals to negative 1 raised to I plus j, where the I is the row, the first row of 1, plus the j is the column, first column 1, is equals to negative 1 raised to 2 times to the least number, the cofactor of 1, is equals to positive 1 times 3 is equals to 3. And now 3 is the cofactor of 1. We will find the cofactor of 2. The cofactor of 2 is equals to negative 1 raised to the number of the row, second row, plus j, the number of the column, 1, is equals to negative 1 raised to 3 times the least number of the cofactor of 2, 4, is equals to negative 1 raised to 3 equals to negative 1 times 4, where is negative 1 times 4 is equals to negative 4. And now, negative 4 is the cofactor of 2. Now, we will find the cofactor of 4, where cofactor of 4 is equals to negative 1 raised to I plus j. I is the number of the row, 1, plus j, the number of the column, 2, is equals to negative 1 raised to 3 times to the least number, 2. Simplify, negative 1 raised to 3 is equals to negative 1 times 2. Negative 1 times 2 is equals to negative 2. Then negative 2 is the cofactor of 4. And now, we will find the cofactor of 3. The cofactor of 3 is equals to negative 1 raised to I plus j, where I is the number of the row, 2, plus j is the number of the column, 2, is equals to negative 1 raised to 4 times to the least number, 1, is equals to negative 1 raised to 4 is equals to positive 1 times 1 equals to 1, where 1 is the cofactor of 3. After we get the adjoint matrix of A is equals to 3, negative 2, negative 4, and 1, and the determinant of A is equals to negative 5. And the formula for inverse matrix of A is equals to adjoint matrix over determinant, and the adjoint matrix of A is equals to 3, negative 2, negative 4, and 1 over the determinant of A. The determinant is negative 5. Simplify, 3 over negative 5 is equals to negative 3/5. Then, negative 2 over negative 5 is positive 2/5. Next, negative 4 over negative 5 is positive 4/5. Next, 1 over negative 5 is equals to negative 1/5. And now, that is our inverse matrix of A.
Algebra of matrices. Here, we are given two matrices, the matrix A and B, wherein A is equals to 2, 1, 5, 0, negative 6, and 3. And B is equals to A, 1, 5, B, C, 3. And it states that if A is equals to B, find A, B, and C. As you can see in the given, 2 and A are in the same place. Therefore, A is equals to 2. And B and 0 are also in the same place. Therefore, B is equals to 0. Lastly, C and negative 6 are in the same place. Therefore, C is equals to negative 6. Here's another given. 5, negative 3, 8, negative 4 is equals to A minus 3, C plus 2, B minus 4, D plus 5. We are asked to find the value of A, B, C, and D. If A minus 3 is equals to 5, we are just going to transpose negative 3 to the right side. It will become A is equals to 5 plus 3. So, A is equals to 8. And the solution that we did in finding A will also be the process of finding B, C, and D. Then if C plus 2 is equals to negative 3, it will be C is equals to negative 3 minus 2. So the value of C is equals to negative 5. And if b minus 4 is equals to 8, this will be b is equals to 8 plus 4. So b is equals to 12. And lastly, if d plus 5 is equals to negative 4, this will be d is equals to negative 4 plus negative 5. So, the value of d is equals to negative 9. Kramer's rule. It is used to solve systems with matrices, wherein I got these three equations, and these three equations were just hypothetical and not the real equation. So, a sub 1x plus b sub 1y plus c sub 1z is equals to d sub 1. A sub 2x plus b sub 2y plus c sub 2z is equals to d sub 2. A sub 3x plus b sub 3y plus c sub 3z is equals to d sub 3. These three equations are also called the standard notation. For us to find the matrix of A sub x, A sub y, and A sub z, first, we should transform the 3 by 3 system from standard notation to matrix notation. So here's it. A will be equals to A sub 1, A sub 2, A sub 3, B sub 1, B sub 2, B sub 3, C sub 1, C sub 2, C sub 3. And here in A sub x, we are just going to change the value of A to the value of D. So it will become D sub 1, D sub 2, D sub 3, B sub 1, B sub 2, B sub 3, C sub 1, C sub 2, C sub 3. Here in A sub y, we are just going to change the value of B to the value of D. So it will become A sub 1, A sub 2, A sub 3, D sub 1, D sub 2, D sub 3, C sub 1, C sub 2, C sub 3. And for A sub C, we are just going to change the value of C to the value of D. So it will become A sub 1, A sub 2, A sub 3, B sub 1, B sub 2, B sub 3, D sub 1, D sub 2, D sub 3. For us to find the value of three unknowns, the x, y, and z, we need to follow this. X will be equals to the determinant of A sub x over determinant of A. Y is equals to determinant of A sub y over determinant of A. And z is equals to determinant of A sub z over determinant of A. So, for the matrix of A, it will be 2, 1, 1, 1, negative 1, negative 1, 1, 2, 1. Then, we need to get the determinant of A. In getting the determinant, we can use the expansion of minor or the diagonal multiplication. Here, I am going to use the diagonal multiplication. It will be, in diagonal multiplication, we need to put this, copy this to column. So, diagonal multiplication. First, 2 times negative 1 times 1 plus 1 times negative 1 times 1 plus 1 times 1 times 2 minus, here, next, 1 times negative 1 times 1 plus 2 times negative 1 times 2 plus 1 times 1 times 1 is equals to negative 2 plus negative 1 plus 2 minus negative 1 plus negative 4 plus 1. It will result to negative 1 minus negative 4. So, the determinant of A will be 3. Here's another given. 5, negative 3, 8, negative 4 is equals to A minus 3, C plus 2, B minus 4, D plus 5. We are asked to find the value of A, B, C, and D. If A minus 3 is equals to 5, we are just going to transpose negative 3 to the right side. It will become A is equals to 5 plus 3. So, A is equals to 8. And the solution that we did in finding A will also be the process of finding B, C, and D. Then if C plus 2 is equals to negative 3, it will be C is equals to negative 3 minus 2. So, the value of C is equals to negative 5. And if B minus 4 is equals to 8, this will be B is equals to 8 plus 4. So, B is equals to 12. And lastly, if D plus 5 is equals to negative 4, this will be D is equals to negative 4 plus negative 5. So, the value of D is equals to negative 9. For the matrix of A sub Z, it will be 2, 1, 3, 1, negative 1, 0, 1, 2, 0. For us to get the determinant of A sub Z, I am going to use the diagonal multiplication. We are going to copy these two columns, 2, 1, 1, 1, negative 1, 2. Then proceed in doing the diagonal multiplication. It will be equals to here 2 times negative 1 times 0 plus 1 times 0 times 1 plus 3 times 1 times 2 minus next 1 times negative 1 times 3 plus 2 times 0 times 2 plus 0 times 1 times 1. It will become 0 plus 0 plus 6 minus negative 3 plus 0 plus 0. It will be 6 minus negative 3. The determinant of A sub Z will be 9. And for the matrix of A sub X, it will be 3, 0, 0, 1, negative 1, 2, 1, negative 1, 1. And for us to get the determinant, do the diagonal multiplication. Copy these two columns. It will be 3, 0, 0, 1, negative 1, 2. So, it will be first diagonal, 3 plus 1 times negative 1 times 0 plus 1 times 0 plus 2 minus, next, 0 times negative 1 times 1 plus 2 times negative 1 times 3 plus 1 times 0 times 1 will be equals to negative 3 plus 0 minus negative 6 plus 0 it will be negative 3 minus negative 6. Determinant of a sub x will be 3. Lastly, the thing that you should remember in using the Cramer's rule is that a should not be equal to 0, because if the value of a will be 0, the values of x, y, z will also be 0, and having those values will not provide or fit to the solution for your equations.